This podcast is sponsored by Scispot, the best tech stack for modern biotech.
We are going to use genomics to help improve IVF outcomes. Right? And that's powerful. Like it's powerful in terms of the way you spend your time during the day. It's powerful in the way it sort of occupies your mind. And it's powerful in the story that you get to tell, and you get to bring amazing people along for the journey because you're doing this really cool, singular, new, awesome thing.
No, totally. I think you have to live and breathe that, and especially when you always have a risk of dying or explode, right? You see both things together because this is going to work, and it can be huge. It can impact millions of lives if it works in your case, especially. So you are excited about that, and you cannot afford doing 10 other things. So you always have to come back, focus, really understand what's the DNA of the company, what's the mission and vision of the company, and then align all the resources, right? Even find people who will align with the vision of the company. Because if you hire people, they don't believe in the startup, it's very hard to grow and create something massive.
Yeah. I think my favorite part about what we're doing and why I joined was that it is really focused on outcomes. It's not like a vanity project. It's really very focused on how do we make this experience better for couples who are experiencing infertility, which is hard, right? You've wanted a child, you've tried to have a child, maybe that's not going the way you expected, maybe you've had losses, and the idea that we could reduce the time that it takes to get pregnant and maybe avoid losses, I think is what really resonated with me. It's not just genetics for fun, right? We're not choosing blue-eyed children. It's really about having a better outcome.
When you say better outcome is basically, so it's more like disease, more like genetic disposition for some genetic disease.
Interestingly, I feel like that's a secondary
goal. So that's what I thought, right? Okay. That's what I thought in the lab, 30 years ago. That's what I thought when we started Juniper a few years ago. And as we started talking to people on the IVF journey and IVF clinicians, so here's an interesting piece of it, right? Most people encounter with their reproductive endocrinologist, their IVF clinician, stops after a heartbeat is detected during pregnancy. They move back to their OBG for the rest of the pregnancy, and then they're with their OBG for
what's OBG?
Obstetrician gynecologist.
Okay,
right? So they're regular sort of maternal health clinician, right? They're not with the infertility specialist anymore. So the infertility specialist generally hands off patients once a successful pregnancy has been achieved. So they report live birth outcomes to a central database in the US and Canada, but they're not generally with the patient through that whole journey. Their journey with the patient stops once they've achieved a successful pregnancy. So from the IVF clinician's point of view, they've succeeded when they have a pregnancy and they've handed that patient back to their OBG, right? And so they're literally, they literally kind of lose that connection with the patient when they've made that handoff. So the idea of something that happens after birth, like the risk of a developmental disorder, childhood disease, which are massively genetic, right? It's now, exome sequencing, whole genome sequencing is first line of diagnostics at a high-end center for all of those kinds of childhood disorders. But it's so far beyond what the REI's journey is, what the infertility journey is. And so that journey in which you're producing a set of embryos, and it's the same for the patients, right? They're there because they've been trying to get pregnant and they have not been able to add a child to their family, right? Sometimes they don't have a child yet. Sometimes they've had a child and then having another child, secondary infertility is much harder. Sometimes just structurally they can't, like my sister and her wife, right? And they still have to sign the form, in Quebec saying, oh yeah, we've been trying for 6 months, right? But their medical intervention is infertility treatment, right? It's the same technology, the assisted reproductive technology for same-sex couples, for single parents by choice. All those people they're there to have a child.
Makes sense. If you don't mind dumbing it down a little bit, so who is your potential or ideal beneficiary, and what is that journey? Is it people who have frozen embryos? Is it people from like same-sex marriages? Is it like, who is this ideal persona, and what is the typical journey right now, and how do you plan to transform it, or how are you transforming it?
Yeah.
So the ideal couple is really anybody who might be pursuing IVF for any reason. And IVF is when you are taking an egg and a sperm and making an embryo outside of the body. But often these couples are going through quite a journey before that time, either because maybe you're a same-sex couple and you're then deciding to have children and pursuing donors, or because if you're a heterosexual couple and you've been trying to have a baby, you typically in the US are waiting a year before you get referred to an infertility specialist. And then when you're there, you're going to go through a bunch of tests, and you may undergo other infertility treatments before you reach the stage where you're offered IVF. So it really can be a very long and stressful journey. Some couples may also end up in infertility because they were able to get pregnant on their own, but they've experienced multiple losses, and there's not an explanation for that. So it really is, it's not like you just wake up one day and you're like, aha, I'm going to go see the infertility specialist. It really is sort of a long process. And, unfortunately, during that time, women are getting older. And as you get older, there are increased chances for genetic abnormalities in the child, same actually for fathers. And so that time matters a lot. And so the ability to bring IVF into the picture perhaps sooner and have a successful outcome sooner is really appealing, not only for the provider, but for the patients. And I think ultimately our hope is, if we can be really successful, then does IVF become an option sooner in that journey?
I see. And when you say sooner, how soon? Is it when the embryo is ready or frozen? Is it when there is IVF process?
Right. So during the IVF process, the overall journey of, like, once you're in that moment, right? You have your egg and your sperm. Sometimes that's the intended parent, sometimes it's a donor, but either way, you've got biological components, egg and sperm, right? They get combined, and you don't just do one at a time, right? You fertilize as many eggs as are available, right? So you'll fertilize, 15, 20 eggs, and then there's attrition. Some of them don't get fertilized successfully, some of them don't grow successfully. By the time you get to about 5 or 6 days, the successfully fertilized embryos have formed what's called a blastocyst. So you've got sort of a ball of 200 or 300 cells, right? The outside of that ball becomes the placenta. The inside, the inner cell mass, becomes the fetus, the embryo, eventually the child. And so you'll end up with, typically 4 to 5 blastocysts. And you don't, we used to, and in our sort of cohort, right, you probably know IVF twins or even triplets, right? Because in the older days of IVF, you would transfer multiple embryos at a time. Right? It's risky for the mom. It's risky for the developing embryos. And so we don't do that anymore, mainly because IVF scientists in the lab figured out a way to vitrify embryos. So now you don't, so you get like 5 embryos and you transfer them all because you had no way to store them. So now, as you alluded to, right, you can freeze embryos, you can freeze eggs, you can freeze sperm, you can freeze embryos, and they can remain viable in that vitrified frozen state. And it's not just like in your freezer, it's in liquid nitrogen, right, at minus 200 and something degrees, right? It's, and last year there was an embryo thawed successfully resulted in a live birth, I think 25 years after it was frozen.
Wow.
So the ability to, so once now that we can do that vitrification process, now so you get 5 embryos, they all get frozen, right? And you transfer one at a time. And so now the challenge becomes, which one do you transfer, right? Because if you're a heterosexual couple trying naturally to get pregnant, right? You try to get pregnant in a cycle. Maybe it grew for a couple of days, but then it didn't. The woman will have her period on the normal schedule. Like, you wouldn't even know that happened, right? You wouldn't know that there was something growing for 2 days and it failed, right? But with IVF, you know every single time you've tried a transfer. And that the emotional journey of that in IVF, it's like there's a hashtag for it. It's like hashtag TWW, the 2-week wait, right? There's 2 weeks between when you've transferred an embryo and when you can take a pregnancy test, right? And see, was that embryo transfer, was that embryo viable, was the transfer successful, right? And the language around this is so problematic, right? Was the transfer successful? It actually turns out that what we've learned and why Juniper, I think is going to be really transformational for families is that at least 85% of the time an embryo doesn't succeed. It's the genetics of the embryo itself. It wasn't that the doctor did the transfer wrong. It wasn't that your endometrial lining wasn't ready. It wasn't that you drank too many cups of coffee or you took the wrong prenatal vitamins or you have a hostile fucking womb, whatever that means, right? The social excuses that we make up to explain the absence of data. But as we gather more data about IVF failure and pregnancy loss, we realize more and more and more that it's the genetics of the embryo itself.